Hi friends, in this video we are going to discuss about the concept of Kirchhoff's current law, that is we are calling in shortcut as KCL. So this is most important topic in electrical circuits. So with the help of this particular concept we can find the currents flowing in individual branches, and also we can find the unknown voltage at the junction points. So that is the reason why this concept is very important. Okay, so now first we are going to discuss about the definition. After that, how we can write the Kirchhoff's current law equation for individual networks. Okay, so just see here, the definition of Kirchhoff's current law is, it is defined as the sum of currents entering into any node is equal to the sum of currents leaving the node is called as Kirchhoff's current law. Okay, just see once again I am defining this definition. It is defined as the sum of currents entering into any node is equal to the sum of currents leaving the node is called as Kirchhoff's current law. Okay, just see here, just see, for example, this is the circuit we have. Okay, first we are going to discuss about the first example. Okay, so we know that here we mentioned that, so this is the node point. Okay, so this one is the node point. Now for this particular node point, how many branches are connected? Just see here, this is the node point. How many branches are connected? Here R1 branch, R2 branch, R3 branch, R4 branch and R5 branch. So all these are the individual branches which are connected to this particular node. Okay, for this particular node all these are connected, and here R1, R2, R3, R4, R5 are the individual branches, means in each individual branch there is a flow of individual current. So that is the reason why here I am mentioned that the current flowing in the R1 branch is I1, the current flowing in the R2 branch is I2, the current flowing in the R3 branch is I3, the current flowing in the R4 branch is I4, and here in the I5 branch is I5. Okay, so R5 branch is I5. It means that for this particular junction point, so for this particular junction point, so these many branches are connected, and individual currents are flowing. So here now our target is to identify how many currents are incoming to this particular junction point or node point, and how many currents are outgoing from this particular junction point. Okay, so now we need to identify the directions, and with the help of that Kirchhoff's current law definition we can write the equation. Okay, just see here, so in this particular circuit, in this particular network, just see I1, just see here, this I1 is incoming to junction, I2 is also incoming to junction, I3 is also incoming to junction, but here I4 and I5 are outgoing from the junction. That is the reason why, as per the definition of Kirchhoff's current law, at any junction point the sum of incoming currents must be is equal to sum of outgoing currents. So because of that particular definition we are writing the equation of KCL depending upon the incoming currents and outgoing currents. So because of the directions of currents towards the junction point and outgoing from the junction point, so we are writing here I1 plus I2 plus I3 are the incoming currents towards junction. That is the reason why, so incoming current, sum of incoming currents is equal to I4 I5 are the outgoing currents, so that we are writing, so I4 plus I5. So here incoming currents are sum of I1 I2 I3, outgoing currents are sum of I4 and I5. So like this we can write the expression of Kirchhoff's current law at any junction point depending upon the direction of current towards the junction or outgoing from the junction. Clear? So this is one of the example. Now here the second thing is, just see, so here example 2. So again we have here, we have junction point here, and how many branches are there here? Four branches are there. One is R1 branch, R2 branch, R3 branch, and R4 branch. Okay, so this one is R3, this one is R4, and this one is the R1, and this one is the R2. So we have four branches, and individual four branches, the individual currents are flowing. Just see here. So for example, this is the junction point or node point. Now what are the incoming currents and what are the outgoing currents? We need to identify here. Okay, just see here. I I1 plus I4. Okay, I1 plus I4 are outgoing. Just see here. This is I1 outgoing from the junction, and this one is I4 outgoing from the junction. But here this one is I3, this one is towards, okay, this current is towards junction point. Here also same, this I2 current is towards junction point. So depending upon the incoming currents and outgoing currents at the junction point, we can write the expression of Kirchhoff's current law at the junction point is what? So I2, I3 are incoming to the junction point. So that is the reason why I2 plus I3 is equal to I1 plus I4 are the outgoing. So that's why we are writing like this. Okay. So this is the example number 2. Now coming to the example number 3. Example number 3 is, just see here. So we are discussing example 3. So for example, this one is the junction point. Now here also same, we have four branches are there. R1, this one is R1, this one is R2, this is R3, this one is R4. So we have four branches, and in individual branches individual currents are flowing. Okay, so here the current flowing in the R4, R1 is I1, and here I2, this one is I3, and this one is I4. So just identify how many currents are incoming to this particular junction point. Just see here, I4 is incoming. Next, only I4 is incoming, and the remaining three currents I1, I2, I3 are outgoing. Okay, just see, just identify here. So this is the junction point. So this one is the junction point. Only I4 is incoming, and the remaining all are outgoing. Okay, so current direction is like this. So outgoing current, only I4 is incoming current. So based on this particular directions of current in individual branches, so we can write the expression sum of incoming currents means only I4 is incoming. That is the reason why I4 is equal to, so how many currents are outgoing? I1, I2, and I3. All these three currents are outgoing. So that we are writing sum of outgoing currents. So incoming current I4 is equal to sum of outgoing currents. Okay. So like this, we can apply this particular Kirchhoff's current law to any circuit. Okay. So thank you so much for watching, and please do subscribe my channel for more updates. Thank you.